Okay, everybody, I'm going to try 3 more questions here. And this will be my last 3 that I make videos for, as fun as they are. I'm going to start with page 6, question number 3. And in page 6, question number 3, it's about an apartment building. And it says you want to maximize the revenue, where it's the number of apartments, I call them the number of items in a generic sense, times the price. So in this particular case, it's going to be the number of apartments, or units they call them, times the rent. So these questions are really from grade 10 math. You want to find out where does it start and how does it change. So when I read this question carefully, it says there's 120 units and the current rent is $400. And they're suggesting that every time you increase the rent by multiples of 10, that's why there's an X there, multiples of 10, you will lose 1 unit. So if X is 3, that means you'd be increasing the rent by 10 times 3, making it 430, and you would lose 3 tenants, and you'd be down to 117 units rented. So there is our actually just a quadratic function that we're going to expand and then take the derivative of. So I've got 48, 1, 2, 3 plus simplifying that, and then as we have been doing all along, once we've got a simplified version of our function, this is a quadratic, I'm going to take its derivative and set it equal to 0. When does r prime equal 0? When 800 minus 20x equals 0. When minus 20x equals minus 800. When x equals minus 800 divided by minus 20, that's equal to positive 40. So they're suggesting that you should raise the rent by 10 times 40. So then the new rent will be 400 plus 10 times the value of x. The new rent will be $800. And at $800, the revenue will be maximized. The next question that I wanted to try is on page 6 as well, and it's question number 7. And in this situation, there are 4 lots side by side, and they each have an area of 480 meters squared. So I've multiplied that by 4 to encompass the whole area and made it 1,920 square meters. Well, they're going to put fences along the sides, and there's going to be 1, 2, 3, 4, 5 fences, all of length X, and then there's going to be a fence along the back part of the property, we'll call that Y, and then the front part of the property as well along the road, that's also Y. So here's what we know about this particular question. We know that X times Y is the area of all 4 of the fields. That's 1920. Then they talk about the fencing, and we've got to break it up this way. There's going to be the sides and the back that cost $15. So I'm going to use capital F for fencing, and I've got 1, 2, 3, 4, 5 X's plus 1 Y plus a second Y, and I'm keeping these Y's separate because they each have a separate cost. So when I look at the question here, number 7, it says the side and back fencings are going to cost $15. So that means I'm going to take the side fence, multiply it by 15, take the back fence, multiply it by 15, but the front fence is worth $20 per meter. So it's a fancier fence, it costs more per meter. That means we've created a cost function, we'll say, and it's going to be equal to 75x plus 15y plus 20y. So the cost function is 75x plus 35y. And then we want to take our known relationship, y equals 1920 over x, and we can substitute that right in there. So your cost function now is going to be 75x plus 35 times 1920 over x. So C equals 75x plus 67,200 x to the minus 1. So now I've got a nice function right here, easy to take the derivative of, and I'll do that on this board up here. So C prime equals 75 minus 67,200 x to the minus 2. And this routine we've done several times. We write it over x squared, and then we find a common denominator to make it a single fraction. That's how I like to consider it. And then you've got C prime equals 75 x squared minus 67,200 all over x squared. So set C prime equal to 0 by setting the numerator only equal to 0. So 75x squared equals 67,200. X squared equals 67,200 divided by 75. And that gives you x squared equals 896. X will equal the square root of 896. So you'll need to break that one down, but you have the value of x, and then we can figure out the length of each of the fence by finding out y. And y will equal 1920 divided by the square root of 896. So simplify that and it will give you the width. Find the length of y, and remember that in order to find the dimension of each property, if that's what's asked, you've got to take your y value and divide it by 4. So each field will have in width, and then y divided by 4 will be the length. The last question that I want to do is on the next page, page 7, and it's question number 15. So when you read this particular question, you'll notice that you have a building A and a building B, and they span this field, and you have to have an underground wire that goes from A across the field somehow to the other side, and then continuing on all the way to B. So one option would be to go straight across, making this one as short as possible, and then have a big long 200-meter span going to B, or you could do completely diagonal, and that would be the shortest distance, but it costs a lot of money to go underneath the field, $1,000 per meter, whereas it's only $500 if you go along the side of the field. So we're going to make a cost function keeping in mind those two values. So first of all, you've seen I've identified the width of the field, 70, and I've broken up the 200 meters into one piece x and then the other 200 minus x. So with that in mind, we've got a right angle triangle here, and the length of this side will be the square root of 70 squared plus x squared, and that's just Pythagorean theorem. So I'm going to take this length and multiply it by 1,000, and this length and multiply it by 500. So the cost function will be $1,000 times the length of this dotted line, which is 4,900 plus x squared to the 1/2, plus 500 times the length of this one right here, 200 minus x. So I'm going to simplify that just a little bit. There's not tons of simplification I can do. And this is the function that I'm going to take the derivative of. And it will look something like this. C prime equals 1/2 times 1,000 is 500. 4,900 plus x squared to the minus 1/2 times 2x. And then just minus 500. The derivative of 100,000 is just 0. So minus 500. So let's work at simplifying that. 500 times 2x is 1,000x over 4,900 plus x squared to the 1/2 minus 500. And so we've had this strategy many times. We just did it again. We're going to take this and we're going to multiply it by 4,900 plus x squared to the 1/2 over 4,900 plus x squared to the 1/2 to find a common denominator and to make a single fraction for our derivative. So c prime equals 1,000 x minus 500, 4,900 plus x squared to the 1/2 all over 4,900 plus x squared to the 1/2. So I'm going to take it from there and take the derivative of that and set it equal to 0. Oh, excuse me, I've already taken the derivative of it. I'm going to take the derivative and set it equal to 0. So 1,000x minus 500 times 4,900 plus x squared to the 1/2 all equals 0. 1,000x equals 500 times 4,900 plus x squared to the 1/2. So I'm going to divide both sides by 500. And I get 2x equals 4,900 plus x squared to the 1/2. So now that we have this situation here, we're going to take both sides and square it. And when we square this, we're going to be left with 4x squared equals 4,900 plus x squared to the exponent 1. So I can transpose the x squared. I can subtract these two terms and get 3x squared equals 4,900. So x squared equals 4,900 over 3x will equal the square root of 4,900 over 3, which is equal to 70 over square root 3 meters. And that's where you want to go with the fence. You want to go down this far, the value of x. It's not a fence, it's a wire. And then you want to have your wire go across the field on this diagonal to this point right here, which is 70 root 3 meters down. And then the rest of the distance, 200 minus 70 root 3, will be the length along here. This piece costs $1,000 per meter, and this piece only $500 per meter. And in doing so, you'll minimize the cost.